Hi, in this video, we are going to look at what is cloud native and what is the CNCF, which is the Cloud Native Computing Foundation. My name is Nipendra Khare and I am the founder of Cloud Yuga. I am also one of the CNCF ambassador. Before I jump into the formal definition of cloud native, let me ask you a question. Would deploying an application which you have and you are running on your local setup or on your servers, deploying it on the cloud would make it as the cloud native app? Well, the answer is no. Just taking the same application what you have and putting it on the cloud would not make it as the cloud native app. But before I talk about that, let me tell you the cloud native definition means different for different people. You would hear different perspective about it, but that's perfectly fine. But the core building blocks or the core blueprint remains the same. So if I look at the formal definition of the cloud native from the CNCF, which is cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private and hybrid clouds. Containers, service meshes, microservices, immutable infra and declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable and observable. Combined with robust automation, they allow engineers to make high impact changes frequently and predictably with minimum toil. Now the definition what we saw has different keywords in it which may look like buzzword right now, but let us now try to understand what these terms mean, which are like scalable applications, dynamic environments, containers and so on. So we would now go over these keywords one by one and try to understand what do they really mean. The first one here is the scalable applications. We know that on the websites we don't have the same traffic throughout the day. For example, during the peak hours you may have lot of traffic on a website, while on the night you would have less traffic. So it does not make sense to run the same infra throughout the day or throughout the night there, right? Because we don't have the similar pattern there. So what we need there is we want to scale our applications as the demand increases, and if we have less demand we want to bring it down. So we want to run such scalable applications which can both scale up and scale down based on the requirements. Now with dynamic environments, we refer public, private and the hybrid clouds. Now with the public cloud, like for example AWS, Azure, Google Cloud and so on, we have common resources like servers, storage and so on. These resources are shared by different companies and individuals. But of course, they'll have the boundaries for them so that they don't interfere with one another. But there is a common infra shared by everyone. Next we have is the private cloud. So for example, if as a company I have 1,000 servers, I can combine all of those servers and make my own private cloud with the software like OpenStack. And once I have my private cloud, I can serve both my internal and external traffic via that. But in the private cloud, we control everything and we have to manage as well. In the hybrid cloud, we put the combination of the public and the private cloud by doing some kind of integration. Now, for example, as I mentioned earlier, you have 1,000 server which can typically serve all of your traffic, but only for a given week or a month. When you have more traffic, you want to add more resources. So what we can do in that case is we can take the help of public cloud and add more resources only for that given period. So that is going to reduce the cost for me because I don't have to provision that additional resources for the entire year. Similarly, for example, some companies want to have their data or the databases within their control. So what we can do is on our private cloud, we can configure the databases or whatever we require, and then we can have all the public facing stuff on the public cloud. So that is also an use case of hybrid cloud. The next term which we saw there was microservices. Traditionally, we have been deploying the applications as a single binary, and we put all the functionalities of a given app inside it. So for example, for an e-commerce app, I am going to put down cart, orders, and all the other functionality in the single binary, which we refer as monolith application, which is difficult to develop, test, and deploy in the current competitive landscape. And it also makes it very difficult to scale out as well. With the cloud native approach, what we do is we take out all of these different components and create a different service out of it. All of these services are loosely coupled and they communicate with each other via the well-defined APIs. So as you can see here, we have taken out different functionalities and created different services like cart, users, orders here. We have the front-end service which kind of communicates with all of them. And they can also communicate in between if there is a need. So with microservices, we kind of give ownership of a given service to a given team, and that team is responsible for managing it completely from development to deployments. The next keyword which we saw earlier was containers, and these containers become the perfect choice of deploying these microservices. So let us now explore what containers are. So again, earlier we have been deploying our applications on the bare metal and then on the VMs. From there, we are now moving to deploy our applications on containers. So if we are deploying our applications directly on the bare metal, our applications are sharing the common resources. Now, if one of the application misbehaves, then technically it can bring down the entire OS, which is going to affect our other applications as well. So from there, we move to deploy our applications on the virtualized system, in which we take the help of hypervisors to create VMs. And now our application's boundary is within that particular VM only. Now, if this application have some issue, then at max it can bring down that VM. It would not affect our host system or other VMs on the environment. But if you look at, our end goal was to run the application, not the VM. So what if I can take the application code, run directly on the host system such that each application behaves as an independent entity, and that we refer as a container. So we take the help of container engines to run these containers independently. These containers are going to have their own IP address, host name, and so on. So they kind of behave like an entity to which we can communicate and perform our regular operations. So containers are going to be more dense. So think about if you could run 10 VMs on a hardware. Now with containers, you can run multiple of them. So just for comparison, if you could run 10 VMs, you could now run 50 containers on the same hardware, which is going to save cost. And because of the containerization, our infra or our application deployments become immutable, which means if you make an application containerized once, then that application is going to run for sure in different environments like dev, QA, and operations, which is going to save a lot of time for us. And that is where containers makes us more productive and cost efficient. We can run these containers on a single host, but of course that would not be a very scalable and the fault tolerant solution. And that is where we need container orchestrators like Kubernetes, in which we combine more than one nodes and form a cluster. Now, some of these nodes can behave as a control plane, and then remaining ones can work as a worker node. Our administrator and the developer can communicate to the control plane to deploy the applications. And then these applications get deployed on the worker nodes depending on the condition what we have set. Now, for example, in this case, we have set up to deploy 3 copies of a given app, and we see that 2 copies went into node 1 and 1 copy on the node 2. Now, for example, if something happens to the node 2, then our application can move to a different machine, and that way our applications would be up and running all the time. And that is what the orchestrator takes the responsibility of. As we are here, let me also talk about why Kubernetes is very important for deploying the cloud native applications. We discussed about dynamic environments, in which we talked about different cloud providers. Now, of course, these different clouds would have different way of doing things. So we need a common layer which everybody can understand, and that is what we can do with the help of Kubernetes. So Kubernetes can become that layer. You can think of Kubernetes is the glue between the different cloud providers. So once we have deployed our applications on Kubernetes on AWS, the same app can be deployed on Kubernetes on Azure. And this would also become the connector for our hybrid cloud as well. So Kubernetes plays a very important role in deploying your applications on the cloud. The next keyword which we saw earlier was service mesh. Once we have deployed our applications as containers on Kubernetes, which is highly scalable, I would now want to control the network or the traffic between them. So for example, when the traffic is going from service A to service B, I want to know how much time it took. I want to encrypt the traffic between 2 services. I may want to put some kind of delay for some kind of an experiment. Now, all of these things are very practical and done in the real world. Now, to do these things without modifying our code, we can take the help of service mesh. So what happens there is, we are going to put down proxies along with each of my application, which is going to give me all of those features. There is another way of doing things with the help of ePBF, which is also kind of becoming reality, which would reduce the number of proxies what we have with each application, but give us all the features which I talked about earlier. So service mesh like Istio, Cilium, Linkerd and so on are going to help me achieve this. Let us now look at the next keyword, which is immutable infrastructure. I would be having different environments like, for example, dev, QA and production. Then think about, I may want to have my environment on different regions of the same cloud provider, or I may want to have my same infra on different cloud providers in different geos. I would not like to sit down every time and create this infra manually. I would want to write this infra as a code and use the tool like Terraform to communicate with my different cloud endpoints to create the same environment as I would want every time. And that is what we mean by the immutable infra. So our tool like Terraform would talk to the respective clouds API endpoints and set up the environment every time the same way. The next keyword which we saw earlier was declarative APIs. In that we have some kind of controller. We tell our controller to perform something and eventually that would happen. So we saw the example of this with the immutable infra, in which we tell the tool like Terraform to create the given infra and eventually it gets created. Similarly, while deploying our applications, we can tell Kubernetes to deploy some applications in a given desired state. For example, deploy 3 copies of an app. The Kubernetes would deploy the right number of copies for me in the Kubernetes cluster I have. So that is what we mean by declarative APIs. The next keyword which we saw earlier was automation. Now, once we have decided to move to the microservices and Kubernetes, nobody is going to sit down manually and deploy these microservices after each pull request what you do in your code base. We need some kind of an automation which would trigger the entire CI/CD pipeline and do it continuously. So we are going to adopt the DevOps practices in which we plan, code, build, test, integrate, deploy, operate, and monitor continuously, along with the right practices of CI/CD. So whenever a code get committed, we would run test cases and then we would deploy that applications in the right environments. So automation is also one of the piece for deploying the cloud native applications. Now, as we have seen all the different keywords mentioned in the definition earlier, I assume now that this definition would make more sense to you. Let us now read out the last paragraph and move to the CNCF website to understand a bit more. The Cloud Native Computing Foundation seeks to drive adoption of this paradigm, which we just mentioned earlier, by fostering and sustaining an ecosystem of open source, vendor neutral projects. We democratize state-of-the-art patterns to make these innovations accessible for everyone. Let us now go to the CNCF website and understand more about it. So I am now on the CNCF website and here I have the projects tab in which we have different categories of projects which are graduated, incubating, sandbox and archived. What does it mean? Now think about I am a company or an individual who built a project which I think is the best way of doing something in the cloud native ecosystem. So for example, I have figured out a way of deploying MySQL in the best possible way on Kubernetes. I made scripts and bunch of other things, and now I want this particular project to be available for all because I think it can help others as well. So I make my project open source. Now, just making something open source does not mean it would be widely adopted and you are going to get a lot of contribution on top of it. You need to make it available to others, right? And that is where the CNCF can help you. With the wide reach of the CNCF, we can apply to make our project under the sandbox stage of the CNCF Foundation. Now here, these experimental projects which are not widely tested would get a lot of traction, lot of eyeballs, and from there it may start getting more contributions, it may start getting more adoption, and that is where it is going to move into the incubating stage. Now, once the projects are being adopted, they're running production and so on, and there are now thousands of contributors to it as well, it then go into the state of graduated. And now if I click on this link, and here I can see projects like Argo, Linkerd, Helm, Kubernetes and much more in the state of graduated. Then we can also see some of the incubating projects also here. Now if you look at the landscape more closely, you will find that there are softwares which are providing the similar functionalities. So for example, Linkerd, Cilium and Istio, all three can be used as a service mesh. But as a true CNCF philosophy, it is not enforcing only one solution. It is giving us the options to choose which works best for us. As CNCF is providing an ecosystem of open source and vendor neutral projects. This is what I like really about the CNCF. Let us now go to the About tab in which we can see who is the force behind the CNCF. So first of all, the CNCF is part of the non-profit Linux Foundation and its mission is to make cloud native computing ubiquitous. You can find out more information about the CNCF from this page. Now, to maintain the projects, to provide them with the right marketing supports and so on, the foundation needs some funds, and that we get from the different members of the foundation. These members are in different tiers, which are platinum, gold, and silver. Now, these members need to pay certain fees to get different benefits. But of course, being a platinum member does not mean that you have any technical say on the projects. Technical say on the projects are done by the technical oversight committee and maintainers. Then we also have the governing board, which is responsible for marketing and business oversights. CNCF also have ambassadors across the globe, which help the CNCF to expand their reach and share the knowledge of the cloud native ecosystem with the local community. As mentioned earlier, I am also one of the ambassador of the foundation. CNCF also provide different courses and certification to get people ready with the cloud native ecosystem. They have different courses on EDX and on their own platform as well. The Introduction to Kubernetes course on the edX, which is a free course. The first version of this course I authored, which was taken by more than 200,000 users across the globe. And there are other paid courses as well. CNCF also provides different certifications for which you can give an exam and then get certified. So for example, there is KCNA, which is entry-level exam to get certification of Kubernetes and Cloud Native Associate. Then for developer, we have the CKAD, which is Certified Kubernetes Application Developer. And similarly, we have the CK for Administrator and CKS for the Security Specialist. Then we can also take the PCA and KCSA exam as well. Apart from this, CNCF also engage with the community in different ways, like running the newsletter, running the meetups and so on. They also do events like KubeCons in different regions of the world. And then we have the KCD, which is Kubernetes Community Day, which runs again across the globe. And I am one of the organizers of the KCD Bangalore, which we have done earlier this year as well. So this was the quick intro about the CNCF. I hope with this video, you would have got an idea of the cloud native and the CNCF itself. I hope this video was useful and worth of your time. Thanks for watching.